All right. We're now live to YouTube as well. Okay. Good, good, good. Sorry, I'm just being stupid with how my windows are. Just the usual. Okay, let me bring up this problem. Ooh. So during the chat there, we had Mamis TV post a question that I wasn't able to get to because obviously we were chatting. Let me bring up the problem on here. Okay. Sine of alpha is equal to 0.8. AE is 10 centimeters. AB is 9. So what's the goal? This is all that was posted. I assume this person isn't still here, so let's type them in Discord. Okay, so I just typed back to them in the Discord asking them what they have to do with this problem. Because I'm not quite sure just from this image. There wasn't any other context that I could find. So let's see if they get back to me. In the meantime, let's, I guess, look for just a question on Reddit. Alcalainer got that. It's probably going to be beyond me, but let's just see. The integral at the top of the page. Yeah, that looks like physics right there. Gotta hand it to you. I mean, there's just a bunch of constants. We probably get to just forget about those. Oh, ooh, you put the dk at the front of the integral, not at the end? Oh, you got some complex numbers in here. Hey, SG1. This is some evil version of the Gaussian integral or something. I don't know. I don't know how you do an integral like this, unfortunately. I can't help this person. Definitely beyond me. Dang it. All right, let's look at a different subreddit. Might just hop right over to an abstract algebra if we can't find anything soon. What is the, what? They're saying negative sign? This is really hard to read. I think they're really just asking how the distributive property works, and we can explain that. Minus w plus 4 minus 5w. At a simpler example, like negative 3 plus 4. This means the parentheses with the usual order of operations, we do whatever is inside the parentheses first. So we do 3 plus 4. Then we remember there was a negative sign in front. So we do 3 plus 4 equals 7. So we make it oh, oh. Talos, thank you so much for the 4 months. Hope you're doing good. How's it going? Oh, Pen's still here? Nice. It's almost Friday. It sure is. Gartic Friday. Actually, yeah, for anyone who's around, tomorrow, there's going to be a whole bunch of people playing Gartic Phone. I think it's going to be a super fun time. If you know what Gartic Phone is, it's like, it's almost like, is Pictionary a good comparison? It's like you just like draw funny pictures, basically, based off other people's prompts. There's a couple of different like game modes too that are like interesting or different like versions. Oh, I need to unpin this. There we go. You're no longer allowed to ask us any questions. You feel awful. I went to metal show last night, then to a karaoke bar. Oh, that sounds awesome, but yeah, probably not good the next day. Who did you see? Like, what band? I love metal. Pictionary plus cell phone, yeah. However, we could also do it a different way if we use the distributive property. Deathclock, Necrogoblicon, and Dragon Force. Ooh, nice. Or the distributive property. Sounds like a good time. I haven't heard of Necrogoblicon, but that sounds like an awesome like name for a band, so. Distributive property says that we can take that minus sign and distribute it to everything inside of the parentheses. So minus 3 plus 4 is equal to minus 3 minus 4, which still equals negative 7. You did not sing any Britney Spears. That was my next question. I'm sure you're a huge Britney Spears fan. Malort? No, it sounds like a word that a goblin would say, as long as we're talking about goblins. Malort. Liqueur. What does it taste like? 1,000 points away from Evil Dawn. Oh, nice, Thunder. The watch tricks are helpful for that. Those numbers got the negative sign, we wouldn't get the right answer. It's well known as being the worst booze ever. See, I assumed that was Everclear or something. So Thunder a while ago, or it might have been someone else, but if you see that oo-wop emote there that Thunder put, someone had me do a self-portrait, but of me upside down. So I drew that, and Thunder like peer pressured me into making it an emote. And so it's called oo-wop, or UOP, because that's Dawn upside down. It looks like Dawn upside down. I should uncapitalize that U, right? It doesn't matter. It looks like that. It was Anders. Okay, yeah. And so Thunder's saying that as soon as they can redeem another drawing, I'm gonna have to do an evil oo-wop. Uncapitalize it, it's faster to write. Okay. Oh shoot, my tea is ready. Give me 1 second, and then I'll go to Twitch and uncapitalize it. You guys can come along with me for the right here as I do my tea. Boy. Just taking the tea bag out of the mug. Gotta throw it away. Now let's get some honey in this tea. And stirring it in. Well, this ASMR is really nice right now. All right, and we're back. Apparently when lore is made from wormwood. Oh! We were just talking about wormwood for like absinthe or something like that. Like some kind of, actually, sorry, my fingers are a little like wet from the steam. Or like, it was something that like Penn Center tried it and it was allowed in Canada but not in America or something. I don't know. It sounds gross. I might be making stuff up as well. So just, love lying. Pure bitter. That doesn't sound good. Okay. Back to the problem at hand. Is that enough explanation for this problem? I feel like with this explanation above, this should be enough for their problem. So I'm just going to send it. How do you do that? That second one, I'm not... I... So 97 is prime. We're talking about for the first one. You can use Fermat's little theorem. 11 to the 96 is 1 mod 97. What? What are the factors of the base? 196, that's 14 squared, right? So if I have 14, you have a... Or I guess like, it's 140 squared? And 7 would go into that. Oh. Well, okay, these are not co-prime though, but that still narrows down the... Does that force it to be 0? No, they can share factors, but not be... If they're... How many powers of 7? Does that matter? Are in 196,000 or 19,000. Yeah, there's already answered. I'm just kind of curious what people were saying about it. What the? Oh. Second comment has a prime factorization. Well, 19,000 is just 2 to the 4th, 5 squared, and 7 squared? That's kind of crazy how small numbers like that make a big number. Okay, this person is using like 5 different algorithms. You know, this just looks annoying. I'm gonna be honest. It's probably the answer though. Oh. Oh, they probably edited their answer. Okay, yeah. All right, I'm moving on. Since you have to use Chinese remainder theorem, yeah. I maybe learned that once. I don't remember what it is though. Oh wait, x has to be congruent to each of the factors independently? Is that what it says? At the same time. Will this be on the test? I hope not. I see a sneaky 420 in there. Chinese remainder theorem. Does it mean something else? I think of like CRT TVs. All right, I'm moving to a different subreddit. Oh, okay. Yeah, that wasn't even on my mind, but yeah. Well, I think the Chinese remainder theorem was probably around first. I don't know. I shouldn't talk out of my ass like that. I only ever hear of that like in the news. I should just stop talking. I feel like I'm gonna say the wrong thing. What? Thanks. Was there a character minimum? There must be. Carrots, radishes, and turnips. Yep. That's what I like. That's true. I'm one to talk about mocking stutters, yeah. Has a person on my Discord, they haven't gotten back to me yet? All right. I mean, we have this one in the pipeline. I just don't know what we have to solve for here. And I'm waiting for the person who asked it on the Discord to write back to me. Maybe I'll check the math Discord. And if nothing there, then we'll really go over to abstract algebra. I don't know, Jed. That's what I'm trying to find out. Is the set of matrices, 2x2 matrices with integer coefficients non-zero determinant with matrix multiplication a group? Oh yeah, that's the general linear group, right? About 2x2 matrices with integer coefficients determinant equal to 1 with matrix. Yeah, that's a special linear group. The thing is, I'm looking at the abstract algebra book quickly here. Because these are like really well-known groups, aren't they? Hey, SPQ. Oh. Oh, that's fair. Okay, that's a good point. I'm glad I didn't immediately reply. So that's why they say it's only integers mod a prime? And not integers in general. The book does. Because I was thinking of... this example right here in the book. And I was wondering why they said that you have to do integers mod a prime. But I guess that's why. Here, I assume being modding a prime makes it integer only. Like it guarantees your math to always work somehow. Yeah. I just didn't expect that answer, I guess, SVQ, but that's what someone else is already saying in the Discord anyway. All right, well, good to know. If P is not prime, then some elements don't have inverses. Right, because if you have like an even number, you can never have 2 times anything come out to be 1 after you mod it. Yeah, so I think this person got it, but or whoever this T person is got it, but it's good to know for my own benefit. This is a trig sub. This is 1/2. It does factor. I don't know if you even want. Oh yeah, you do want to factor it, so you can. It's already. It's equal to 1/2 t plus... How does that factor? Is it 2 root 2? That wouldn't get you the 2 in the middle. If you just have 1/2 t plus 2 in parentheses squared. So I think you're gonna... I think you would complete the square. You're gonna have like a leftover... You can split that 8 up to be 4 plus 4, and then you can complete the square. I mean, you can take out 1/2. Why would you? I don't know. I think it's just going to be a trig sub. You have to simplify it first, though, and you're going to end up subbing, I think, with tangent. And you have a plus there. I'll let them hash that out, though, because I don't want to be another voice. It's like some kind of line integral, but in French. I don't know. Oh wait, did they say what the C is a closed curved in 3D space? Oh, because they did translate it. I don't feel good enough in my multi-variable calc right now. Let's look more into that though. Wait, why are they asking you a different question now? Oh wait, find the length of the curve, I see. This is where it came from. I think that's how you do it. Maybe, go ask Paul what the arc length formula is for multivariable. Why aren't I finding it? Here it is. Okay, yeah, so you do... Do you have to square each component? Yeah. You derive each component, you square it, you add them together, and you square root on the outside. So they didn't square the individual things. Thanks for that, math professor. I still don't know if I'm going to type in this, but because other people are kind of getting to it. But it should be 64 plus 4t squared. Is that going to be simpler? Oh, if it does factor to perfect square, you'll be in business. 64 plus 4t squared plus 1/16 t to the fourth. Do you get a perfect square out of that? I can't keep track of all this in my head. To the fourth. That's probably easier to factor out the 1/16. I'm just using this for scratch work right now, basically. 16, that does go into 64, right? That's why I did this. Yeah, it goes into 32, so 4. Okay. This would factor, multiplies to 4, adds... Ooh, that might not be factorable. Ooh, yeah. Ooh, wait. Really? What? It factors to that? Oh, because you multiply, not divide. Duh. That's why I was... yeah, okay. That makes sense. When I factored out the 1/16, I did 4 divided by 16 and 64 divided by 16, but no, you would multiply them. I feel like I've made that same exact mistake before. Okay. That's the thing that's rough about the math Discord. Cause I don't really want to be another voice in this one. So if I don't have anything unique to add, I'm just gonna move on, but I just got the idea for myself. Ooh, I'm not good with this type of logic stuff. Yeah, I don't know. Oh, geez. This looks like it's going to be something terrible. Let's see, though. They just provided the answer key. I'm going to make it bigger. Yeah, what's up, Critical? I better switch over to it, like right now even. N squared e to the minus n, okay. The sequence converges or diverges, not the series. If it converges, find the limit. Okay. A sequence, okay. So yeah, sequences are nicer because you can just take the limit like it's any like calculus limit. I believe there's no like tricks here, right? And this looks like it's gonna, I'm gonna assume it's gonna go to 0. And we can use L'Hopitals to do it. Yeah, so we just take the limit normally. All right, so let's do that. Let's forget thing. I have an idea for how I can like do this problem stuff a bit better, but it's gonna take a minute to actually figure it out. Wait, when did cosine? Wait, there's no cosine problem that you posted originally. Critical. Are you talking about a separate problem? Oh, okay. Yeah, please let me know what the right one is. Okay, that's a hard. Ooh. I still expect it to be 0. It's gonna be a little harder to prove that though. I think you're gonna have to sandwich it or compare it. So we can do what you said with using a double angle or half angle, whatever. I don't think we need to though. It's probably more helpful to have it as cosine squared. So let me show you my idea here. We want to set the limit as n goes to infinity, cosine squared n over 2 to the n. Make sure I got that problem right. Cosine squared n over 2 to the n. Okay, good. So on top, we have cosine squared. Cosine itself is restricted to be between 1 and -1. So like you have something that's restricted to be, you know, it's going to be a small number all the time, divided by a number that very quickly becomes huge, 2 to the n, because that's, you know, exponential growth. So you have a small number divided by a huge number. I'm going to suspect this limit goes to 0. And so we can't use L'Hopital's here because cosine of infinity, it's not really a number. Cosine just it oscillates. So well, L'Hopital's doesn't really apply here, I don't think. And even if it did, you just go around in circles and you wouldn't get anything particularly meaningful from deriving this. When you have a trig function like sine or cosine involved in this, I think you generally want to do some comparison stuff. We want to show that I'm going to suspect that this goes to 0 for the reason that I said, small number divided by huge number, which generally goes to 0. The same way 1 over x goes to 0 because 1 is a small number, x becomes a huge number. So we know the cosine stands between -1 and 1. So cosine squared is at best going to be between 0 and +1. So I think what we're going to have to do is we're going to have to say that the limit as n goes to infinity of cosine squared n over 2 to the n is less than or equal to the limit as n goes to infinity of 1 over 2 to the n, because of this relationship is true. And we also know that it's going to be, it's not going to go below 0 because positive number divided by positive number. Yeah, so now it's become something that this limit over here is something that we do know how to solve now, because you have 2 to the infinity is basically infinity, 1 over infinity is 0. So we get this nice squeeze theorem or sandwich theorem or any of the names that you may have learned. So this limit must be 0 if it's both less than or equal to 0 and greater than or equal to 0. I pointed out the wrong one, so I said that, but this is how we'd prove that this limit goes to 0. These ones with the like, whenever you have trig involved, you usually have to do some kind of comparison like this. Oh yeah, so I didn't see when you asked if we need to use squeeze theorem, but yeah, that's what we ended up doing. No worries, Critical. Thanks for the question. If you have more, please keep them coming as well. Sounds good. In the meantime, just so we have something to look at. Let's make sure that, okay, yeah, this one is still active on the Discord. I don't know if I'll be able to do this one, but let's just see what it's about. Oh, it's an IB problem? Okay. IB was never a thing in the high school that I went to, so I know very, very little about it. It seemed like a potentially interesting problem, so I wanted to see what it was about. Wait. A small smooth ring of mass, or a small smooth ring R of mass M. So that's the big circle around here. Oh no, it's the small one. Okay. It's sort of onto a smooth wire in the shape of a circle. Okay, so the wire in the shape of a circle is this big circle. I was getting confused because I thought the wire would be straight, so it'd be that line there, but it's not. The ring R is attached on one end of a light elastic string of natural length L in modulus of elasticity mg. The other end of the elastic string attached to A, the lowest point of the wire. Point B is on the wire, and OB is horizontal. Okay. The ring R is at rest at the highest point of the wire as shown in figure 6. The ring R is slightly disturbed from rest and slides along the wire. When R reaches point B, the speed of R is V, and the magnitude of the force exerted on R by the wire is N. I don't know if I'll be able to do this, but let's show that V squared is equal to 2GL root 2. This feels like an energy thing. Where when it's at the top, it has mass times gravity. They do talk about forces, though. That's about zombies. I thought I unpinned that. Is it not unpinned on your screen? Let me open up my own stream. No more questions allowed. Okay, at least on my end, it's not pinned anymore. Yeah, if anyone asks a question, that's an instant ban. No, that's a joke. You can still see it? Oh, that's weird. I don't know. If someone wants to ask me a question, I don't care, I guess, so. It's just like weird that I mean it does say us, I guess, so maybe someone who just went to the stream will think it's me, my imaginary friend, but you know, what else is new? Okay, so if you have, I think this first one is energy. If you have potential energy here, is mass times gravity, depending where you put the origin, times L or times 2L? If the origin's at the origin, or at O, if the origin's at the origin. I don't know, is there a convention for this? It shouldn't matter though, it should be the same answer. So I guess let's put the origin, I don't know, to me it's sooner I should have put it down here at A. So if you have m times g times 2L equals 1/2 mv squared, does that work out? Where does the root 2 come from? Well, oh yeah, so when you get partway down, you're only halfway down the ring, so you have a sum of potential energy and kinetic energy. You have half the previous kinetic or potential energy. I'm still not sure where that root 2 comes from though. Oh, sorry, I forgot to mute my mic for that. Sorry for the ASMR gulps. Um, I can't figure out where the root 2 comes from. I might just leave this problem alone. Yeah, I could say just have a triangle of some kind, but I don't know. Let's move on. Wait. I forgot there is the answer key. I didn't set it up right or what? EPE? Yeah, I don't know what that is. Okay. I'm kind of getting done with this Discord already. I'm not doing that. All right, yeah. Let's go over to abstract algebra. Discord. It's just the problems that I actually can help with. I usually get scooped up faster than I can figure them out. So. Okay. So the last time we were doing abstract algebra, we skipped way down and did like 49 or something. No, we did 50. But let's go back up to the top and I was getting a panic attack for people trying to help. Yeah, exactly, Thunder. So if someone else is typing in one of those Discord chats, I just refuse to type for myself for the most part. Unless they're really like missing something, I have something important to add. I just feel like I'm going to confuse whoever I'm trying to help, which isn't my goal. So. Man, these questions are kind of boring, but let's at least, I feel like I've done 2 and 1, so let's look at 3. Which one are commutative? Subtraction? Certainly not. Because 2 minus 7 is not the same as 7 minus 2. Wait. Never mind. No, yeah, no, it's not the same. You flipped the sign. Okay. Division of non-zero real numbers. No. 4 divided by 2 isn't the same as 2 divided by 4. Chapter 2, yeah. Were they, like it ends with the shoes and socks property. This is probably when I'm going to start falling behind Pen Center more, because I'm, I might be able to keep up a bit, but this one I'm gonna want to spend some time on it because this is mostly new stuff for me. Oh, I think we did do. I remember talking about commutative polynomial composition, and it's not commutative. There's some special cases where it is, but those are exceptions. Multiplication of matrices, nope. Exponentiation of integers, also no. Okay, so none of those are commutative. I feel like I did 4 actually, as well. I think the answer was yes, no. Multiplication mod 15. Is there anything else that's relatively prime to 15? 8 isn't in that list. Can we engineer something that... I mean, these problems are just kind of boring. That's why I'm like zooming through them, not actually doing them out properly. Okay, 1, 4, 7, and 13. Like, I'm looking at C. Is this one closed? 1 times 1 is fine. 4 times 4 is 16, which gives you 1. 7 times 7 is 49, which gives you 4. 13 times 13 is 169. Teehee. Which is 4. Wow. One times all is fine because 1 is the identity. 4 times 7 is 28. Which is 13. Wow. Okay. 4 times 13 is 52? Oh, duh, yeah, because a deck of cards. 52 mod 15 is 7? Somehow this one is actually looking pretty closed. The last one to check is 7 times 13. I feel like there's a trick for this one that someone was telling me. I don't remember, so I'm just gonna do it the hard way. It's 91, 7 times 13, which is 1 mod 15. Okay. I guess it's close somehow. They are all relatively prime, but I guess you don't need every relatively prime number before 15. God dang it, I forgot to mute my mic. Let me go put my mug away. How about 1457 multiplication mod 9? No way this one is closed, right? 4 times 4 is 16, which is 7, right? Oh yeah, sure, Thunder. 5 times 5 is 25, which is 7, wrong. Okay, 7 times 7 is 49, which is 4. Wait, are these all the relatively prime? No, 8 would be in there, and 2 would be in there. Okay. So 4 times 5 is 20 is 2. Ah, that's the one. Yeah, I remember, I think I've done this one before. No, actually, I remember finding that same counterexample now. Okay. 5, I'm pretty sure I haven't done. Okay, in each case, find the inverse of the element under the given operation. 13 in Z20, which I believe implies addition mod 20. And the inverse of 13 in mod 20 will be 7, because 20 minus 13. I did this one too. I remember doing 13 in U14, which is addition, or sorry, multiplication in mod 14. And the trick for that, it's actually good to remember the trick, because it's not intuitive for me. You do 13 minus 14 is -1. And then what do you do after that? It's instead of doing 13 times something mod 14, you can check -1 times something mod 14, right? Oh, you check all the other elements of the group. Okay, anyway, let's put a pin in this one, look at Thunder's question. Ooh. Okay. This one has come up a few times on stream recently. You understand until the 6th line. Oop. Too much. So show the derivative of arcsin x is 1 over root 1 minus x squared. So 6th line, 1, 2, 3, 4, 5, 6. The negative, why don't they consider the negative of the square root? Hey, Polly Agrangian, welcome in. You know, we missed you too. So this is a different way than I would have done it. Why are you allowed to? Why are you justified in dropping and not considering the negative here? It's a good question. Yeah, sure. So arcsin your y ranges from -1 to +1. No. What is it? Arcsin? No. Okay, yeah. So x is from -1 to 1. Y is from -pi/2 to pi/2. So cosine between -pi/2 to pi/2 is always positive. So you expect a positive result. Yeah. That's the reason why, Thunder. Your theory is right, I think. Oh, I said the same thing as you. So arcsine of x is restricted from -1 to 1. Y is restricted from -pi/2 to pi/2. So cosine for pi/2 to pi/2 for anything in that interval is always positive. So it must be equal to a positive number here. So it's exactly the same thing that you were saying. So this is actually a third way that I've seen to do this now. Because I would have, from this line here, I would have subbed y for arcsine x and then drawn a right triangle to simplify cosine of arcsine of x. You can also just look at the arcsine graph and just assume the gradient is positive. Ooh. What do you mean by gradient? Like the slope of the tangent? I know why that would be relevant here. And gradient might be the proper word. I just don't know it in this context. Yeah, it's like the little squiggle. Yeah, so it is always an increasing function. I don't think that's relevant here though. The relevant bit is just the domain restriction, or the domain and range restriction. You know that y is always between -pi/2 and +pi/2, and so you can apply that same restriction to anything you do after. Arcsine being monotone increasing. No, not necessarily, Thunder. Actually, well, would it? Unless there's some crazy thing. Oh, I get what you're saying now. No. You might be right. It might be kind of reverse logic. I see what you're saying. So sorry, no, I was understanding your theory. That might be a good idea too. So if you know the graph of arcsine x, you're expecting a positive result for the derivative. Yeah. So if you're finding the derivative, that feels like it's potentially sketchy, but it definitely works out here. Yeah, I guess that works. I feel like maybe there's some other complicated situation where it might be too simple of a way of thinking. Where like if there's only one step of the problem, I wonder if you could potentially make an error with that. But for this problem in particular, it certainly works. Yeah, okay, that's creative. I didn't even like think of that interpretation. No worries. Get $10. Oh yeah, that's a good call. Oops, sorry about that. Shaky. Okay. You know, I'm 13 is its own inverse. I remember now, because the shorter way to do it, you're gonna go sleep now, Thunder? All right. Well, thanks so much for hanging out and for the question. I'll see you around. So yeah, the trick to do part B here quickly is instead of doing 13 times every other thing, mod 14. Are the chapter 3 questions? No. Let me just like get through my train of thought here, and then I'll look at them. So you would have to do 13 times every number in U14 in theory, including 13 itself, and mod it with 14 and hope you get 1, because that's the definition of the inverse. But you can make your calculations a lot simpler if you know that 13 mod 14 is equal to -1 mod 14, so you can do -1 times every other member in the set, and you end up with -1 times 13 is right. Okay. No, you're good, Fembox. Like if you ever like a thought like that, feel free to type it in chat and I'll like get to it the next time I have a second. So what is chapter 3 even about? Finite groups and subgroups. Or about the order of a group, order of an element. What's happening here? Oh, okay, let's not worry about that. Yeah, they're back to those like geometric like transformation groups, I guess. It's like which ones looked especially like crazy, I guess, or like which ones would you want to like point out to me? Q star be the group of non-zero rational numbers on multiplication. I guess I don't know this notation, so I don't know how easy or hard that is. Is that gonna be everything like commutes with 1/2 maybe? Or something? I don't know. If it's a dish, no, it's probably not that. I don't know. The group generated by 1/2. I'll have to figure out what that means, I guess, when I get to chapter 3. I remember learning something about like generating. I was about to say functions. I don't know if that's the right term for this. But yeah, you can like generate groups from a base element or something. Repeating the same operation to itself. Oh, okay. So I guess if you're doing addition and multiplication, it's still going to be infinite, right? Yeah. Yeah. So, yeah, my first guess that they were commutative was completely wrong, but everything. You may also define it as the minimal subgroup containing 1/2. Minimal like cardinality, I guess, or 14 was the first one that looked hard. If A is the only element of order 2 in a group, then A lies in the center of a group. I guess I can't figure out how hard this is going to be for me because I don't know. I haven't learned any of these concepts yet. Order of an element is the smallest positive integer n such that g to the n equals the identity. So if there's only one thing that when you square it you get the identity, then it's abelian? Wow. Yeah, I don't know how you go about doing that. Hopefully we get the tools, or hopefully... The intersection of all the subgroups containing 1/2? Ooh. See, I mean, I definitely know how I do this right now, but I'm not too worried about it yet. My philosophy with the math is that anyone can learn any level of math they want. It might take some people more time than others, so I'm expecting it to take more time for me to learn this than it would for others, but if I gotta spend some time on it and feel stupid, then it's something that I'm willing to do. The inverse of n minus 1 in u of n for n greater than 2. Oh, is it always going to be n minus 1? Because we just did an example here. So certainly it's going to be self-inverse for n minus 1. Which I'm sure there's a deeper realization that we can make here. Because you can do the same thing with, you do n minus 1 mod n is equal to n minus 1 minus n mod n. So you just get minus 1 times something mod n. And that's always going to be n minus 1. So yeah, okay, n minus 1 is always self-inverse for u of n. Not because it's my first time, Anders, because I don't particularly like abstract algebra, and I'm not particularly good at proofs. I think otherwise I take the same amount of time as anyone else who's learning this for the first time. So I mean, I'm definitely gonna be slower than, like, you know, you or Penn Center, because or Fenvox, or, you know, whoever, because, you know, you guys are more experienced with abstract algebra than I am. But I mean, like, relative to a student taking class for the first time, or, you know, just reading this text for the first time, like me, I think I'm going to be slower. Said -1 times a -1 equals 1. Oh, yeah, for what you get after the mods. Right. I was skipping that step in my head. Because when you have two things multiplied mod n, you can split it up into, you know, a mod n times x mod n, or, you know, whatever, and then mod n again. So you can engineer it to get -1 times -1 is equal to 1 mod n is still 1. Okay. Three minus 2i in C star, group of non-zero complex numbers under multiplication. So I'm going to assume that the zero that's being removed is, like, both parts of the complex number are 0. Just still allowed a purely real or purely imaginary number. I think that's how that works. So the inverse of that under multiplication, you do the conjugate. Actually, wait, what is the identity is still 1. I assume you do the conjugate and you divide by the magnitude? We should check that, though. I think they gave it to us up above. Yeah. Conjugate divide by the... Ooh, not exactly. One is plus, one is minus. I don't think it's that hard to actually like prove this. It's a little bit of calculations, but that's a typo in the book? Oh my god. I would say that makes like no sense to me. I assume it was maybe some complex number that like, you know, you had some I squared for that one or something. Yeah, it's this is, I'm sure it's a reason, but this is just like taking the determinant of a 2x2 matrix to me. Like, you know, it feels very analogous. See, up here where they prove it, they do get the denominators right. Oh, complex. Oh, really? Okay. That's good to know, Anders. I can hopefully be more careful with my phrasing. I probably won't be, but I can try to be. So we have, I'm just going to do this mentally because I'm too lazy to get up and go to the whiteboard. If we have 3 minus 2i, we're going to take the conjugate, the complex conjugate. I already messed it up. 3 plus 2i. And the magnitude of this is, actually, you don't do the square root. Which is kind of interesting. I think because, why don't you do the square root? Because you need to make them both unit vectors, basically. Because you're doing a plus bi times c plus di. You need to get rid of both their magnitudes, is how I'm going to justify that. So you multiply by the square of the magnitude, which is just the same thing, both no square root. Always wrong, there's a typo in the reference table. Yeah, that's a really bad error to have, Box, you're right. Okay, so we have 3 plus 2i, and you're going to divide it through by 9 plus 4 is 13. So the conjugate is 3 over 13 plus 2 over 13i. Okay. I feel comfortable doing everything in number 6. I'm not going to bother with these. Oh, well, we should do one of the mod ones. Okay, let's do part D, because we're gonna have to get the determinant anyway. I should get practice with matrix in modular. GL is multiplication. Oh, yeah, it's multiplication. Okay. Okay, so we have 2, 1, 1, 3. We're modding 7, and we want to find the inverse. So, let's find the determinant. 2 times 3 is 6 minus 1. Oh, well, I mean, that just comes out to be 5. So that's not a very fun mod 7, but are we going to get fractions? Are we breaking math? Switch the corners, negate the other corners. What's happening? How does this work? Because you would normally, like, I think the book mod 7 before you multiply in the fraction, but like, I feel like we're gonna have an issue here, aren't we? How do we deal with this 1/5? Is that determinant? I know, never mind. The determinant's defined. So it is GL. Didn't make that bad of a typo. Do I? Remember how blown away you was the first time your math theory teacher showed you how you can deal with fractions in modular arithmetic? It'd be great to know. 1/5 is the multiplicative inverse of 1? What? Oh, a 5. Okay. Math professor says, been well since I did this. So you find 5 mod 7? That's still 5. 1/5 is the multiplicative inverse of 1. Or 5. Ugh. No, you're good, math professor. What does that mean? It's the multiplicative inverse of 5. Can you... So meaning 1/5 is like, for general multiplication, it's the multiplicative inverse, but like for multiplication mod 7, 5 has some other inverse. Assume to 5x equals 1. Well, we only have integers mod 7, don't we? Oh. Solution to 5x equals 1. So what I'm doing in my head is I'm taking 5x equals 1, doing mod 7 of each side, but then I end up with 1/5 still. And that's surely not what you're supposed to do. So 5x equals 1. I still don't see it, I'm going to be honest. 7 is prime. 5 has to have a multiplicative inverse. Oh, it's 1/5 is going to be the same as whatever the multiplicative inverse of 5 is. We just have to translate it. So what's the multiplicative inverse of 5 mod 7? Okay. 5 times what mod 7 gives you 1? 5 times 2 doesn't work. 5 times 3 5 times 3. So 1/5 is equal to 3. Okay. That's so weird. So which, yeah, okay. So, like, we're saying that 1/5 is equal to 3 in Mod 7 land? That's so weird. 3 times 5 equals 1, so 1/5 equals 3. This makes me intensely uncomfortable to write, but in this case, I guess it's true. Oh my god. Well, thank you for that, Femvox. Jeez. 2, 4, 4, 6. You know, just to be sure, I'm going to multiply these back out, because this is just a... Oh no, it's not just a multiple. It looks like it's just like a scalar multiple, but it's not. And I guess if you're doing things mod 7, that might not even be such a bad thing. Or that column times that row. 2 times 2 is 4, plus 4 is 8, is 1 mod 7. Checks out. And that column times that row. 2 times 4 is 8, plus 6 is 14, which is 0. That column times that row. 2 plus 12 is 14. Wow. Times that. 4 plus 18, 22 is 1 mod. Wow. The math works. All right, we didn't break math. Abstract algebra PTSD. All right, that's a huge save for Fembox there. That means 1/3 mod, or 1/3 mod 7 is 5. I guess it would be. I hate that fractions like that come up in like integer modulus multiplication, whatever. I can't do words. All right, so I'm glad I chose that problem to do because that was instructive. Okay, let's look at 7. Give 2 reasons why the set of odd integers under addition is not a group. Well, if you add 2 odd integers, you get an even integer, so it's not closed. It's probably associative. The inverse is always 0? No. There is always an inverse. It ain't closed. Hey, Brian. Because you can always do the negative of whatever you have. So what's the other thing that we need? An identity. It's 0. So what's the other reason? There's no identity? Oh, 0 is an odd. I guess, is 0 odd? Or is it both even and odd, or is it neither? You're saying yep, so I assume you're saying that's neither. Is 0 even or odd or neither? 0 is even. Oh, wait. Oh, duh. Yeah. You can't express 0 as 2k plus 1. You can express it as 2k. Okay. Yeah, my bad. Yeah. Okay. Thank you for that. That's a save. As well for Brian for pitching with that problem. Oops, there we go. Can we view Fembox? Yeah, I forget how the leaderboard... Enigma made a leaderboard command? I don't know. Okay, so I guess those are the top savers in my chat. Jed, Stuki, Zone Ranger, Fembox, Pen. Seems reasonable. I just said the number of saves, though. Oh, yeah, there's that, too. So the elements of U of 20, isn't that... Are you just naming every number relatively prime to 20 that's less than 20? So it's going to be 1, 3, 7, 9, 11, 13, 17, and 19? That seems too simple. But I'm going to go with it. 1, 2, 3 under multiplication. Real Xenomorph, thanks for the follow. Oh, a real Xenomorph, that's crazy. Show that 1, 2, 3 under multiplication mod 4 is not a group. Sounded good to you? Alright. Xenomorphs do math too? Salutations, you know? Maybe I was being judgy. I'm sorry. I'm sorry for prejudging you, real Xenomorph. If you want to be a Xenomorph and enjoy math, then you're welcome to do that. Thanks for the 5 bits, Brian. Welcome in. So 1, 2, 3 under multiplication mod 4 is not a group because 2 times 2 is 0 mod 4, so it's not closed. You feel very welcoming. But 1, 2, 3, 4 under multiplication mod 5 is a group because 5 is prime, so you're never gonna have anything. It is closed because you never get to 0. Show the group. Can you also be a complex xenomorph instead of real? So look at number 10. Oops. Show the group GL2R of example 9. Oh, not exercise 9, but example 9 above. It's non-abelian. Just find 2 non-commuting matrices. That should be pretty easy. So look at example 9 though. Make sure we're not missing anything. If you're real, you're complex by definition. Alright, so yeah, just find 2 matrices with determinant not 0. Or... yeah, not 0. I'm gonna make Wolfram Alpha do my dirty work. Two, 1, 3, 4. I declare a thumb war. 5, 2, 1, 4. What does that come out to be? Watch, I just imagined some inverse or something, right? No, okay, good. That comes out to be that. Now let's reverse the order. I will from Alpha interprets that right. Nope. Okay, yeah, these do not commute. You get 11, 8, 19, 22, 16, 13, 14, 7. There, bam, easy. Let A belong to a group and A squared or A12 equal E. Express the inverse of each of the elements a to the 6th, a to the 8th, a to the 11th in the form of a to the k. Ooh. A chatbot for your stream. That'd be a cool project. So the inverse, it's going to be 12 minus the current power of a, isn't it? So the inverse of a to the 1 is a to the 11. The inverse of a to the 11 is a to the 1. A to the 6th will be a to the 6th. A to the 8th will be a to the 4th. Electrical engineering. Ooh, cool. Yeah, so I guess since you're new, how the stream like works is I take math questions from ideally from people in chat, but when things are slow, like now there aren't questions to be had. I go through and do some like just studying just for my own like benefit. So I'm doing some abstract algebra studying right now until someone asks a question, and it's very like early on in this, but yeah, welcome in. Hey vegans, I'm doing good. How about you? Good to hear. All right, so question 12. In U of 9, find the inverse of 2, 7, and 8. Oh, jeez. Okay, that's a nice stretch. On your Twitch feed, finding some decent content. Oh, nice. Well, since you gave me an opening, there's plenty of other math streamers out there that are also great. Those are the ones I can recommend the highest in that list. So you're interested in more math streamers, but there's a list to help you out too. And vegans, if you have a question, let me know. If you're just here to chill, then that's just as good too. No switches. Is this active math? Yeah, it's very niche. But we are out here. And I should say there's also Phobo Stream was in this list. Who also streams math, and then I haven't seen a stream in a minute, but Math Professor's been hanging out in chat too. So there's even more people there. So, oh, nice. Well, hey, there you go. Run new Math Professor stream tomorrow. They're prepping for APs and finals. Oh, that's fair. Sure, vegans. Oh, Incritical, you're back. Yeah. Let me know. For 6 hours. Oh, geez. Oh, critical. That's something that you just have to know. Really? Give me a good explanation of a Google. Here. E is defined as the limit as n goes to infinity of 1 plus 1 over n to the n. And except you, instead of a 1 here, you have a 2 there. And I think that makes it e squared, but let me confirm that. So I don't remember how this limit definition actually works. So can you express it like a change of variables? Or like what? Like like I remember there being a formula with like instead of a 1 you have an A, and the quotient of n is a B. But I'm trying to remember like this right here. That u equals n over 2. Oh, okay. I just want the end formula here just to confirm my e to the AB, right? Okay. So critical. You just have this is something you just have to memorize, to be honest. I guess that's what they expect you in like a normal like calculus class. If you have a limit of this form up here, it's e to the power of a times b. So the answer there, you do limit as n goes to infinity for the problem you have, and you just say it's equal to e squared. They usually treat it as like an identity. I should look up how this thing actually works. Oh, they do the same thing. Except they say x equals. Oh yeah. Okay. Oh no, critical. It's just e squared. It's not infinity. Oh no, sorry. B is the coefficient of n, so b is 1. Like, b is the coefficient of the exponent, not the exponent itself. So they're using x here, but it's b times x in the limit as x goes to infinity. So it's just, you have a 1 in the exponent there. The other thing they could give that's like that is sine x over x, or sine n over n, I guess. Well, as a sequence, how would that... yeah. Well, no, they wouldn't give you that. Never mind. There's a different one, though. Maybe there isn't. I don't know. Vegan says you have 2n people who are different sides, with n being a natural number, and you put them in 2 rows, so each row has n people. How many combinations are there when the person in front is always smaller than the one behind? So the first row is n, the second row is n minus 1. I feel like I've had this exact same problem before. I don't remember what conclusion we came to, though. No problem, critical. Wait, are there only 2 rows? Oh, I misinterpreted this question completely. They're literally asking about like the size of the people. Doesn't it depend? Well, I guess. Let's see. I don't know. I expect to be able to read German. We can plug it into Google Translate though. I think you probably got it right though. It's gonna be too annoying to get it translated. Toonie, the person who just joined my Discord, are you listening to the stream right now? Oh, I don't see them typing. Sorry, there's someone who just asked a question on Discord. Let me respond to them. Give me 1 second. Okay. So if he can, I mean, we can actually just look at the picture. Might, I don't know. Let's see. Only we had Spectre here. Okay. Anyway. So I think sorry. Yeah, that's how I'm interpreting it now, Fembox. At first, I had some completely off the wall interpretation, but I think you're right, and I'm hoping that there's only one possible way for, or like all the same people have to be in the back row, and all the same people have to be in the front row. I have a hard time justifying that so far, though. If you can make that claim, then it's just 2 times 2n choose n, right? Or n choose n, or two times n choose n, I guess. Oh, Linux physics, you're translating. Thank you. Also, ranges are there, the person in front should be smaller than the person behind them. Okay, so can we make the claim that it feels so general, I guess? Like, is there a world where you can switch someone from the front to the back row? I feel like there is. But if that is true, like, how the hell do you solve this question? Actually, it wouldn't be n choose n like I was saying. It'd be n permutation n, right? See, the order matters. This would be n factorial times 2. Is that it? No, well, yeah. If we can assume that you can't switch people from the front to the back or the back to the front. Does factorial take precedence in the order of operation before multiplication? That's a good question, Brian. I think so. Because normally you need to put those parentheses around for someone to interpret. If you have 2 times 3 factorial, I would treat it as the number 2, then separately times 3, like you do the 3 factorial first, then times 2, unless it's in parentheses. That's my instinct, at least. I don't know if that is actually true. This sketch for n equals 6, I don't think is that helpful. They're all the same size. So yeah, try it for 4 people. Let's try Googling this. Thanks to Linux Physics' translations. Might be able to find an English version of this. Algebra combinations in general are 4 factorial. Oh. That sounds right. Go away. Actually, well, let me just look more at. There are 2n factorial over 2 factorial, 2 factorial, 2 to the n. That's a nice way of analyzing it. You have 2n total people. And because you're choosing pairs, why do you divide by 2 to the n? The answer is f as in f this. You know, I agree, Hardlocked. So the tallest person called a multinomial. Oh, okay. Multinomial coefficient. The first person can go with anyone. The second tallest person, or sorry, the tallest person can go with anyone. The second tallest person, assuming they weren't chosen, can go with n minus too many people. Yeah, I'm confused about that part, I guess. That sounds like it's right. As for n equals 6, I might be able to do it by hand as well. Hmm. Um, what is the probability of the person in front? Wait, so look at Linux Physics' translation for part 2 now. What is the probability the person in front is smaller than the person behind? Are we forcing that to happen? Unless we're now saying this, we're doing this randomly. Oh, okay, yeah. For part B, I think we assume like randomness. Small person has to be in the front row, the biggest has to be in the back row. For part 2? Or part B? Is that true? Because to me, it seems like, unless that's part of the original question in the first ask. Oh, okay. So for the first one, I would say what Fenlock said, or I would go with what Fenlock said. It definitely sounds right. Oh, it's 2 times n, not 2 to the n. Okay, that makes more sense. I think the answer for part B is going to be based on the answer for part A. Dann Sprechens the Deutsch? I sure sprechen. No, we had a translation in chat from Linux Physics, but yeah, I agree with that, vegans. So, oh wait, it is 2n over 2 to the n. Okay. See, I mean, I don't have a better idea than what Fenbach said, vegans. I'm not sure how, I'm just not good with these questions, I guess. So unless you have anything else, I'm gonna move on to, I'm gonna go back to the abstract algebra. Yeah, I would think so, Fembox. Was I doing this one? I think I was. The inverse of 2 in multiplication mod 9. Oh, jeez. So the elements of u of 9 are 1, 2, 4, 5, 7, and 8. Um, 2 times 5 gets us 1. So 5 is the inverse of 2. 7 times 4. 4 is the inverse of 7. And then for 8, 16, 32, 40, 56, 64. So 8, oh yes, 8 is self-inverse, of course. We've been over that. Translate each of the following multiplicative expressions into its additive counterpart. So it's, this one is a plus b plus b plus b. Assume it's commutative. All right, so now we get into inverses, which, do we want to do the inverse first or the squared first? Does it matter? They go over exponents somewhere. Here. We do the inverse first, and then we add it that many times. Okay. So this would be negative a plus negative a, because a inverse is negative a under addition. And so negative a squared is negative a plus negative a. Oh, because it's commutative, you get to do this little trick with the parentheses now, where you can distribute the 2 to each one. You can't generally do that, but this is Boolean, you can. So this is negative a plus negative b plus negative b plus c plus c. Part C. Why is it equal to E? I guess you'd say negative a plus negative a plus negative a plus negative b 6 times in total plus c is equal to 0? And that's as far as you can go? For group elements a, b, and c, express ab cubed in a, b negative 2, c negative 2 without parentheses. So here we don't get to assume commutativity. So ab cubed is ab, ab, ab. This next one, let's do this on the board. Let's stop being lazy. Gotta use the shoes and socks theorem on that one. I need to rotate this freaking whiteboard. I hate this ugly splotch. So what's our problem again? Express a, b, -2. So to the -3? To the -2. Without parentheses, okay. So we need to break out the parentheses. So let's start by applying the definition of a negative exponent. Squared. Now let's use the shoes and socks theorem on the inside with a -1 exponent. So you reverse the order. So a, b, -2, c inverse is c inverse b squared a inverse, right? Squared. So now when you square it, we don't know that we're commutative. So the best we can do is this. And I think that's how that works. How do you call operators that are partial maps in English? Like they're not closed? Or like if it's a partial map, maybe it's not onto? Is there a word for that? Not being onto? Matrix multiplication. Oh, are you talking about that, like monoid or whatever the other term is? Well, like groups that fail one of the properties, one or two of them? Like if there's not necessarily an inverse, it's like monoid. Okay, monoid in something. It's not a binary operation. Well, I feel it depends on how you define the sets, right? If it's just a set of all matrices, I feel like that's just you're sort of saying it's just an operation rather than a binary operation. Yeah, I don't know if I understand the question, Anders, I guess. Like, what the version of a binary operation is if it's not closed? Like, what? It seems like it'll just be an operation. Consider all pair of matrices as the domain, some multiplication may not be defined. I mean, if you're allowed to already have an m by n in, or what did you say? And if you multiply, if your set already includes an n by m matrix and an m by p matrix, why can't it also include an n by p matrix? I guess that's where I'm confused with that example. Function composition. There aren't necessarily inverses for functions, or what's the issue? Okay, yeah, fair. And so what's the word for that where it's not complete? If you're trying to compose, but there may be functions in there that just don't compose? Is there a word for that? Yeah, I'm not sure. If you know the word in Spanish, I could try to like translate it to English, or like, you know, into Google Translate things, or I can try to find something on Google, but I don't know what that word would be. What's up, critical? Because I mean, I would think you just call it an operation, I guess, rather than a binary operation, but I guess I'm not the person to ask when it comes to algebra terms. Arctan of ln of n? Ooh. What's happening there? Hey, Kervin, over on YouTube. So ln of n as n goes to infinity still is infinity. So what is arctan of infinity? Isn't that pi over 2? I'll explain this in more detail in a second. Just look at the graph of arctan to make sure I'm not completely crazy. Good. Okay. So yeah, critical. This one I would do intuitively. So it's arctan of ln of n. So let's start by figuring out, let me write the limit first. Let's work away from the inside out here. So just for now, let's just worry about the limit as n goes to infinity of ln of n. Ln of n looks like this, and even though it looks like it starts to level up, it does grow without bound. It will eventually go all the way up to positive infinity. So this is still equal to infinity. So I would say that the ln of n inside here is basically irrelevant. And we could just think about this problem as basically the same as the limit as n goes to infinity. Because this infinite, like, element doesn't actually change what's going on, n is still going to infinity. So it's not actually changing that much in regards to the limit here. So we may as well just look at arctan of n. And arctan, this is the reason why I looked up the graph of it, looks like that. And unlike ln, it actually does have hard upper and lower bounds at y equals pi over 2 and y equals minus pi over 2. So as n gets very big, arctan of n will approach pi over 2. So I'd call that the result for the limit. You could have some other scenario. Like in this case, we got a little bit lucky because the ln and the n to infinity kind of agree with each other. You could have some other scenario where you have to like actually end up like flipping things. Dang it. So if you had some other scenario with like limit as n goes to infinity, arctan of like 1 over n, that will be approaching 0 on the inside, and arctan of 0 is still 0. So in that case, it'd be like doing the limit of arctan as n goes to 0, rather than 1 over n to infinity. So it's possible that you get some flipping stuff happening, and it's not always the exact same infinity to infinity, but in this case it was. So if that makes sense, critical. No problem. So I think we're on 15 now. Suppose that A and B belong to a group and A to the 5th equals E and B to the 7th equals E, right? A negative 2, B negative 4. Ooh. How? What's the idea here? Oh, I get it. If you know A to the 5th is E, then the inverse is this the inverse of A squared? Which should be A cubed. I think that's what we want. So I think a to the negative 2 is equal to a cubed. And b to the negative 4 is equal to b to the 3. Whereas over here, if we choose and socks this, we'll get b to the negative 8 times a to the negative 4. So b to the negative 8 is an interesting one. I think it'll be the same as b to the negative 1, because you can take away a 7, which means b to the 6 times a to the 1. We're on page 78. I want to go back and look and check the answer on this one. Good. Wait, b to the negative 11. Can I not do math? Oh, I didn't do the second part right. I assumed commutativity by accident. This doesn't seem... Where's b to the negative 11? Where does that come from? You have me fooled. I should probably be writing this down rather than doing it in my head. Oh wait, I did say it was a cubed, b cubed. Why did they get b to the... What? I don't get their method. Their method here. I think I feel like I did my own way that also works. So I'm just gonna take it and run. A cubed, b cubed. In this one, I think I would have done it right if I didn't assume commutativity. So okay, let's go back through it again. It'd be first taking the inverse of the inside. It's b to the negative 4, a to the negative 2, and then on the outside you have squared. B to the negative 4 is the same as b cubed. A to the negative 2 is the same as a cubed. So you get b cubed, a cubed, in parentheses, squared. So it's b cubed, a cubed, b cubed, a cubed. And I think I added those exponents because I assumed that they're commutative when they don't have to be. Okay, was it 558? Nope. Law theory, oh gosh. Let's pray we don't get that far. Okay, good. An A cube, B cube. Okay, cool. Show set as a group under multiplication mod 40. I remember seeing Penn Center do this one. It was a really funky group. Let's explore it for ourselves here. This one's probably worth working out here. 5, 15, 25, 35. 5, 15, 25, 35. So let's make a Cayley table. Okay, 5 times 5 is 25, which is still 25 mod 40. These calculations are gonna get a little crazy. 5 times 15. Oh wait, you can no, it doesn't help you. 5 times 15, which I'm to the old-fashioned way. 75, which is 35 mod 40. 5 times 25 is 125, which is 5. And this should be 15. Because it's like Sudoku, you can only have one number in the column or row. We do expect it to be commutative, because it's multiplication. So we know that as well. So 15 squared is 225, which is 5. Right? No. It's 25. Because 40 goes into 200, right? 40 times 5? Yeah. Okay. Are we gonna have 25s on the diagonal? Because 25 to 25 is 625. $35 times 35, I don't know off the top of my head though. $12.25? Which 40 goes into 1200? 30 times, so that's also 25. How about 25 times 15? Can I work that out in my head? Should be a trick, right? 25 times 10 plus 25 times 5? Wait, did I even do that right? Yeah, I did. 25 times 10 is 250, plus 125 is 375. 375 mod 40 is 15. 15 times 35. We can do the same trick, right? 35 times 10 is 350, plus 5 times 35. 165 plus 350? Is that it? 165. 35 times 5. Yeah, 165. 165 plus 350 is 5. 165 plus 350. 515? That doesn't sound right though, right? What is 515 mod 40? Wait, we should know this. We expect this to be 5. Does 40 go into 510? That doesn't... No way. Okay. Do it the old-fashioned way. No fancy mental math tricks for me. It's 175 plus 350, really? 525? Does 40 go into 520? If 40 goes into 400, it should go into 520. So, okay. We just need that spot and that spot, which are the same number. 25 times 35. Oh, hey, Lee Algebra. Sorry, I didn't see that, but thanks for the help on that. Sometimes use negatives. Oh, I keep forgetting about that, Fenbox, you're right. How painful is it to prove mod multiplication is associative? Probably a huge pain. All right, well, at least for 25 times 35, let's do the negative trick, right? Because 25 times 35 mod 40, this marker's dying, man, is the same thing as negative 15 mod 40 times negative. No, that doesn't help. We make just one of them negative, right? So let's do 25 times negative 5 mod 40, which is negative 125, which is definitely a number, mod 40. Come on, I can do this. We want to get 160, so is that 35? Oh, duh, it has to be 35. Okay. Both negative is even better? Really? Oh, you're right. Negative 15 times 5. You get 225 mod 40. And what, 40 goes into 180? Is that what that's saying? Doesn't make sense. Wait. Negative 15 times negative 5. No, I'm bad at math. You get 75 mod 40, which is 35. Okay, never mind. Okay, so that's that. What was the question? Is a group under multiplication mod 40? What is the identity? We just showed us closed, right? I'm just going to say that it's associative. I don't want to bother. It's multiplication to the associative. That's all the justification I'm going to have. We want inverses. We need to identify the identity, though. The identity is 25? Yeah, the identity is 25. So we do have an identity. The inverse, well, the inverse of 5 is 25. The inverse of 15 is 35. The inverse of 25 is 5. The inverse of 35 is 15. Okay. So I'm going to take that as my verbal proof that it's a group. And so this group in U8 is where things got cool. So U8 is multiplication mod 8. Be 1, 3, 5, and 7. Mod 8. So let's do the K table for that. And I expect it to be just a scalar multiple here. This math should be much simpler. Wait, say the inverses again. Each element is its own inverse? Is it? Oh my god. I keep wanting the smallest number to be the inverse. But no, the inverse is 25 which means every element is self-inverse because the 25s are on the diagonal. Like I was going for the 5s. Thanks for getting me to pay attention, Anders. Weirder than it, yeah. Okay, so 1 times 1 is 1 mod 8. 3 times 3 is 1 mod 8. 5 times 5 is 25 is 1 mod 8. 7 times 7 is 49 is 1 mod 8. Already have that diagonal matching. 3 times, that'll be 357. Oh god, dude, this marker, it has to be retired for now until I buy new ink for it. It's getting too bad. Wait, am I doing this too quick? This doesn't exactly match up there, but maybe that's okay. Oh yeah, I remember, yeah, this gets like remapped. So 5 times, it's like 1 isn't the same as 5, 1 is the same as 25. That's why it looks different. 15 mod 8 is 7. 21 mod 8 is 5. 35 mod 8 is 3. Okay. So in this, it's basically, this is basically the scalar multiple of that, but there's some remapping that happened along the way. So 1 got mapped, the new identity is 25, we said. How do we work out what else got mapped where? Is it a simple saying like 3 is mapped to 35 because that, and 5 is mapped to 5? 7 to 15? I guess so. It seems consistent everywhere. Just using the inside of the table as the key? Hey Abdallah, how's it going? It doesn't just scale by 9 or by 5? Not exactly, Lee Algebra. I think it's pronounced Lee. I hope it's pronounced Lee, even though it looks lie. I feel like I've been corrected when I called it lie algebra. So yeah, it's not just like a, it's not the exact same as this. Well, I mean, it is, but it's rearranged, I guess, which the rearrangement part is kind of weird. I don't understand why, but this is something I remember seeing Penn Center do over on his stream. I don't know if there's some kind of better realization that we can get out of this. Okay, you're a poser though? Should be 2 isomorphisms between them? I believe I don't remember what isomorphism is to be honest, but I'm sure we'll get there eventually. And yeah, by the way, Lee Algebra, since I haven't seen you around before, my normal kind of shtick is I prefer to take math questions like from chat and solve those, but if things are slow like they are now, I've been studying abstract algebra from this textbook, and it's my first time really studying abstract algebra. I studied it a little bit once before, but I'm on page, what, 78? Studying using this book here. So yeah, and then I dual stream to YouTube as well. So if you hear me talking to someone who's not typing in the Twitch chat, they're probably in the YouTube chat. They're both isomorphic to the integers mod 2. In an elementary abelian 2 group? Oh wait, integers mod 2 cross integers mod 2. What the heck? Applied math major yourself? Oh, cool. So height underscore. Every finite elementary abelian 2 group is isomorphic to integers mod 2 to the n for some n. So since order 4, you get that. So yeah. One day I'll understand those words, I guess, to speak you. For now, I'll just have to believe you. um, all right, so number 17. When setting abstract groups of 4 elements, you show only 2 structures possible: integers mod 4 and integers mod 2 cross or times integers mod 2. Huh. You know, I think I remember Anders like saying a question like prove every group with I think 5 elements or less is abelian, and I feel like that seems like it's kind of a consequence of what you're saying, underscore. Didn't you say that? If a group has 5 elements or less, it must be abelian. And if it feels like if it's related to the if it's related to integer multiplication, that can be another way to justify that. I mean, no, it's only that underscore I said that for 4 elements, but I went for 5 elements there. It's like another thing too. Yeah. So I don't know enough to like say anything about any other case, but there's a cyclics, but we didn't cover the topic yet. Okay. I think that's the next chapter, or at least we get into them at first. I don't know, I was trying to make connections in my head. The dihedral group, order 6, is the smallest abelian group. Wait. Non-abelian group, you mean? Because we're just saying how if it's order 5 or less, it must be abelian. Oh, okay. By reasoning with the orders of elements, things we find a power such that g to the k is the identity. Okay. Classification theorem for abelian groups is one of those big results. Okay. Order one should come next. Yeah. I did do a sneak peek at the next chapter. I still want to spend some time on chapter 2, but we're gonna take the orders of groups and stuff in chapter 3. Okay. Okay, so 17. Let G be a group, and let H be all X inverse such that X belongs to G. Show that G equals H's sets. So this is one of those things that seems obvious, because if every element has to have an inverse, and the inverse is a member of that set, then they should be equal to each other. How would we phrase this, though? I feel like normally when I have a problem like this, I can get the gist of what the idea is, but actually writing the proof out tends to be my issue. Oh, that didn't come out right. G5H? Yeah, dude, that's what I wanted. Wait, I proved they're subsets of each other. Which I guess what we have to do is, like, actually doing that is gonna be a little weird. Okay, so first let's prove that G is a subset of H, right? Yeah. Set R is both open and closed. Oh, honestly, bijection doesn't mean that much to me here, so I thought bijection was only for functions. If it means something with sets, and I actually didn't even know that. So I guess we'll start with, like, let X belong to G. Then X inverse belongs to H. We have to, well, if we let X belong to G, we have to get, for this half of the proof, that X also belongs to H. So I guess since H is a group, oops. X inverse inverse, because we know it should have an inverse, belongs to H. But X inverse inverse is equal to X, so X belongs to H. Is that how we do it? Can you say the inverse inverse is the original thing? That inversion is surjective? Involution? I don't get this thing. Finding bijection between G and H implies they have the same number of elements. Oh, goes one to one and onto. Okay. So then I guess for the other half, don't we do almost the exact same argument? Let an element X belong to H. Yeah, why don't we do the exact same argument? Just feels lame. I don't know. To just reuse the same argument. I know. I keep doing that. It's probably better to use the same argument twice if you can, but. Actually, it's the same as sets, right? I guess we are doing that. Double inclusion is better. Okay. Or is the first thing you think of? All right. Or inversion. Therefore, G equals H. Box. There. Oh. You're right. Okay. So we can't do the lame thing and reuse the same argument twice. The second part of the argument works, but you're right. H is not necessarily a group, or else we haven't proved it yet. But I think we can kind of do the same thing just in the G world, right? Why do I keep doing that? I keep making the same typo over and over. I think when I write A, it starts the same movement as a G, and then my brain goes 200 miles an hour, and I just go straight to the P, I guess. I don't know. So X inverse belongs to H, but X inverse equals X, so X belongs to H. Is that how we make the argument? We just stay in G until we're ready to hop over to H now? Okay. Okay, so that always takes a little more like refinement than I initially thought. Oh, and milk. I did see that, but I forgot to address it. Phone will show that set R is both open and closed. I know that's true. I don't know how you show it. Oh gosh, who all was helping out here? Show me the other argument or guide me into it? I guess so. Just give out some saves here for everyone who helps me out with that one. Hopefully I'm not missing anyone. Okay. You see, the save is just like a for fun like tracker if you make a good point on a problem that I'm doing where you help me out. Oh yeah, you do need a username, which for you it's going to be weird, but So the other argument was... Oh, I see what the exchange was between underscore and the algebra. Okay. I was just saying, because I was like thinking about the problem. It's enough to check that inversion is an involution. What is an involution? Oh, of course, it's the shrinkage of an organ in old age or when inactive. No, in math. Function transformation or operator that is equal to its inverse. Oh. It's self-inverse? Okay. Oh, okay, and underscore, you give me the definition there. Prove F is bijective. Actually, well, I'm kind of curious for an example of this aside from X. Like, what other function is self-inverse or an involution? Can you do like 1 minus X, or is there something cute like that? No. I don't know. Complex conjugation? Oh. Okay, yeah, I would never have thought of that, but I guess so. Anyway, prove F is bijective, so... How would you prove that's oh gosh, how do you prove it's bijective? You start by proving surjective and injective. How do you do that, though? The only fact we know is that f of x is equal to x. Does that imply that it's invertible? Which might give us a lot of this for free. Planar symmetry over a line? Oh gosh, okay. Oh, 1 over x, that's a nice call. I mean, that seems like it. Call that bijective if and only if has an inverse. Oh. So it's just like a one-line proof. Like, if f of x equals x, then f equals f inverse of x. Therefore, it's bijective. Okay, you know, I'll write down the board. If f of f, well, actually, let's write the definition of f first. If f maps x to x, and f of x equals x, prove f is a bijection. And I feel like by the definition of an inverse, f of x is equal to f inverse of x. which is all the work that we have to do. So if it has an inverse, if it's invertible, it is a bijection, according to what SPQ said. But there's the part 2 that underscore kind of outlined for us, which is how the heck do we use this fact up there? If do we take a function that maps G to H? How do we... Wait, I'm getting confused on like the elements being the inverses of the original, I guess. It maps G to G. F of x equals x inverse. Oh, okay. I don't know what this does yet, but that's, I guess, how you'd express it algebraically. It maps G to G and is an involution. So he's having to know inverse by H? I don't know what's happening there. Well, I mean, so, okay, I've gotten to that this function is self-inverse. So it's a bijection. So this is a bijection between the sets? And so we're done? Okay. Sorry about that. Okay, well, that's simpler than I thought, I guess. Sneezing. Yeah, I managed to mute my mic before I actually sneezed. Well, thank you for the alternative way to solve this one. All right, so 18. What's the members of K equals all x squared such that x belongs to D4? And D4 is the dihedral group of order 2? Or of order 8? I forget if you multiply or divide by 2. I assume 8. I don't know what a dihedral group of order 2 would be. Or no. Oh no, yeah, I would know. No, I wouldn't. No, I don't know, dude. Is it the number of sides or is it the my god. Okay, D4 has to do with squares. Okay, that's what I needed to know. It's order 8, but it's denoted by D4. Okay. Because it has 8 elements. Okay. So K is the perfect square of every element in the dihedral group? Or like it's each element squared? Okay. And then L is all x belongs to D such that x squared, so everything such that x squared is the identity. Let's go back up to the Cayley table they give in chapter 1. So the square of R0 is R0, the square of R90 is R180, the square of R180 is R0, the square of R270 is R180. So already we've just chopped off R90 and R270 completely. It's everything on the diagonal, so R0, R0, R0. Oh, okay. So we get R0 and R180 only. The identity, the second part of the problem is all x squared such, or all x such that x squared equals e. So going let's say diagonal, everything that gives you R0. So R0 is in here, R180 is in here, and all of our flips are in here. So you've only chopped off R270 and R90. Underscore. During my teacher national contest, one of the questions was, show the set of subsets of X containing X has the same cardinal as the set of subsets of X not containing X. That's a lot of sets and subsets. The answer provided was A to X minus A is an involution. Huh. So you found a bijection between them. Or you said it was a bijection. There is a bijection. I don't know how, but I guess complementary. Yeah, it's like set subtraction, where like all of X, but not what's in A. Oh, I guess that's that's almost like a common. Oh, I only just now noticed that your name is Lee Algebra. Algebra. It's funny. That's why I said you're an imposter. I guess that's like a kind of nice way of thinking about it. Just name all the sets including all the subsets including X, and then just remove the X term. That's like a nice intuitive way to me. Prove the set of all 2x2 matrices with entries from R and determinant +1. Oh, so prove the GL of 2R. No, SL. is a group under matrix multiplication. It's probably a good one to do, right? All right, let's do it. It's going to be a lot of writing. As for the associativity, I'm going to phone it in. Because that's just terrible to do. Wait, determinant 11? That's not right. Dude, copy pasting from the book does not work out too well. Oh god, there's a hyphen in determinant as well. Ah, who cares? I'm leaving it. You know, we're also going to put it in for closure. Because the real interesting part of it is with inverses, right? And identities. Well, the identity is easy as well. It's closed. Trust me. Associative. Wait, associate. Why can't I spell associative, man? Associative. Same. And then we want to then we show the identity. 1, 0, 0, 1. That is determined equal to 1. I guess we can verify that. Okay. Didn't they like show this in the book? I feel like proof by box. Yeah, PDFs do suck for that. Proof by even the one correcting my paper is bored by that question. Yeah, this question is kind of boring the more I write it out. Have you seen subgroups already? That's the next chapter. I assume the real answer would be that the special linear group is a subgroup of GL or whatever. Oh, okay. I was about to wonder how this next step worked. Okay, so I was like, I was getting weirded out because that's not 1 like I expected to get. But that happens to be the same as the determinant, which is 1, so we'll be okay. So that's how this formula actually works, I guess. I don't know that. Here you get minus BA plus BA is 0. Here you get DC minus DC is 0. Here you get minus BC plus A or DA. Oh, look at that. And AD minus BC is equal to 1. So 1, 0, 0, 1. Technically, we should do it the other way around also, right? For we really don't have a life. I think it's going to be the same exact thing though, right? prove that GL is a group. That's true, SPQ. Prove this instead of me. Yeah. I mean, spoilers for math, I mean, I guess I don't really care that much about, but it's AD minus BC. 0, 0. Well, would you look at that? You get the identity again. All right, so that question was kind of actually really boring. I thought it'd be more helpful, but the only real goodbye marker. The only real trick was that AD minus BC is one thing, so meh. Meh, I say to you, question. Oh yeah. Boring but important. That's fair. Determinant of inverse of A. Oh, that's true. I should add that on. Oh, really? A cell group into GL supergroup doesn't exist as a rule. For any integer n greater than 2, show there are at least 2 elements in U that satisfy x squared equals 1. So there should be 2 elements that are self-inverse. So we already found one in an earlier question. Where is it? Where is it? This. N minus 1 is its own inverse. 1 is the other inverse. Okay, I get it. Should we... How do we show this, though? I do remember how we show it. Let's just write it out for fun, which is, by fun I mean for boring. Let's write this out for boring. Yeah, I was thinking exactly that we can prove that the det is a homomorphism GL to R to the power of star, and that you establish SL as the kernel of the determinant. I was just about to say that. Sorry. It's like, you know, feeling smart sometimes. Yeah, associativity for matrix operations seems terrible. My claim is that n minus 1 squared equals 1 and 1 squared equals 1. Mod n for u of n. Okay. Maybe the mod n parts are done if I can write for u, but who cares? I would hope that 1 squared mod n equals 1 is sufficient proof. And then n minus 1 squared mod n is what we'll have to do some work on. So let's, I guess, break it up to its own. They each get their own individual mods. And then these, you can do n minus 1 minus n. And I think that's the point here. And you get some nice cancellations. Do you? I hope you do. Wait. Yes, you do. Now we can combine this back to do -1 times -1 mod n, which is 1 mod n, which is 1. There we go. Like that Poincare, Ponca, whatever action is 2 by 2 matrices on the Ponca. Dude, I'm overthinking because you have the accent over the E. Normally I just like pronounce it without hearing. You just don't want to prove the associativity. I assume that's also like a similarly painful calculation to do. That's really, it's a lot of work to prove something that seems obvious, I guess. So you have in here now the unitary group? I don't know by that name, at least. They define U of n to be modular, or multiplication mod n in the set is all relatively prime numbers up to between 1 and n minus 1. No, you use all the French verbiage you want, underscore. Oh, okay, interesting. Yeah, I didn't know that notation is also used for a different thing. Oh, is this gonna be some more check digit stuff? Oh, never mind. It's not a check digit thing. From group under multiplication mod 91. So how could we solve for this? Well, it should be closed. So you have to use the closure. Oh, it's gonna be so annoying to check though. This really happened. I'm fascinated that this really happened. Is there an easy way to check this? I don't want to do 81 times 81 mod 91. I guess you can say it's the same as -10 times -10, which is 9. Proof by control F. So I assume the issue is closure, and so you have to check which one would violate closure, and then add whatever you get into the set. It just seems kind of tedious to do it in this case. Let's use Wolfram Alpha, I guess. I'm not doing all this modular arithmetic in my head. 53. Do we have 53? Going once? Yep. 9 times 22. 16. We do have 16. 9 times 53. I don't know if there's like a trick where you can just look at it and know. 22. 74. 29? 29! Alright, that wasn't that bad. We got lucky. Write a Python script to do that? Yeah. Be pretty quick, I guess. Oh wait, why is my... How did my Firefox get like this? What the heck? I didn't even notice that. We live in 2024. Yeah. Let G be a group with the property that for any XYZ in the group. Oh! Left-to-right cancellation implies commutativity. All right, this one looks fun. Just have to get to 22 to get to the actual problems here. I think do I get the idea? I don't know. We'll find out in short order if I get the idea, I guess. Oh my god, set problems. Got 99 problems, and spelling is one of them. Oh, thanks for the follow, Lee Algebra. Appreciate it. Oops. This is like some sub-implication stuff, I guess, or... Wait, am I even writing this down right? XY equals ZX. Oops. I mean, I did a different version of it. I guess I did right-left. Implies Y equals Z implies abelian. That's the problem. So I assume we start, oops, yeah, we start with this and we just start playing around with it. How does this actually work now that I write it out? Because I feel like the cheating way is to say it must be abelian, or, you know, we just say it's abelian, and then we get to here? Is that actually, is that, no, that's just what you do, isn't it? So like right here, if I use that it's abelian, then I can get to Y equals Z. That seems stupid though, right? But you can't possibly get from point A to point B unless you use the fact that it's abelian, right? I feel like I'm not structuring this proof right. I think... I think this is what I'm given. I need to stick to what I'm given, maybe? So maybe we should instead say that if we're given xy equals zx and y equals z, then should we instead say that xy and then we substitute y for z? I guess we could even, I don't know if doing the flip side matters, but is that the proof that it's abelian with the given information? I feel better about that. That's an even number problem. They just don't give answers for the evens, right? They sure don't. Yep. All right. Ah, 23 looks boring too. Draw an analogy between the statement AB inverse equals B inverse A inverse in the act of putting on and taking off your socks and shoes. I get the metaphor. It's just weird, the question that says that, I guess. Now, the next part of the question might be kind of interesting. Find distinct non-identity elements A and B from a non-abelian group. Oh, for the last one? Aren't we given that Z exists? Or is that... I don't get the issue underscore. I thought we were just given Z, weren't we? Let me know if there's something wrong with what I did. If not, I'll just keep on reading through 24. Oh, like, the start would be let xy such that xy equals ex. You need to say why you can do this. I guess so I didn't introduce it well enough. Like, I should have said let G be a group with a property that for any X, Y, Z in the group, or let G be a group with a property that for any X, Y, and Z in the group, X, Y is equal to ZX. I guess implies Y equals Z. You do want the entire thing. Basically repeating that first statement over again? Or am I misunderstanding you still? It's like you could say let X be real such that X squared equals -1. So that's clearly not a true statement. Or it's an impossible statement. In any group for any X and Y, you can find a Z such that XY equals ZX. Is that, I would say the proof starting with that? Well, wait. I thought we just get to use this for free. Like, we don't have to worry about justifying the thing that we're given in the problem. Like, we're not determining, like, when that's true. We're just saying, you know, if we're given that it's true. Do we have to prove that such a Z exists? So wait, so we have to go from XY to ZX, or I kind of lost. So Phobos is saying XYX equals XYX implies XYX equals XYX using associativity. By the assumption of the Oh. Oh. Wait. That's such a weird manipulation. So if you can get to the point with xy in parentheses times x equals x times in parentheses yx, then you apply this piece of information. I feel like, okay, that's like a clever way of finding what that z is. I thought it'd be unnecessary to find that z though. C equals xy x inverse. Yeah, so I'm kind of like, I think like the algebra maybe agrees with me. I would hope that we just get to use that for free. Like, I don't know. It's weird to me that we have to justify the thing that we're given. But maybe I'm just not completely understanding what's happening. A special choice of z leads to the proof easily. Yeah, so like the whole being present implication kind of confused me too, but I feel like my way of doing this is pretty simple. I don't think I've done anything too crazy. I don't know. Maybe I have. Equals to xy x inverse. I mean, it is for any xy. I don't know. I don't know if I'm right or wrong or what the criticism is anymore. Like, why should you be allowed to choose x, y, and z, I guess? It has to be for any x, y, and z. You're assuming that you can pick y equals z from, says the left statement implies y equals z. I'm using the implication in the wrong direction. Okay. Well, God damn it. I feel like we should be able to take these as both true. I don't know. Like... I don't know. It is phrased, yeah. Well, my professor is saying we're given that the implication is true. We can use both sides of the implication, even though in other situations you should absolutely not go from the right side of the implication to the left side. In this case, we're given both parts are true, I would think. So, yeah, I feel like I'm okay. I don't know. Proofs are weird. Yeah, that's kind of what I was, I guess, thinking at first. Because like when I first wrote the top line on the board, that's when I like had that little realization, like, oh, it is an implication, but we write it in parentheses. It's not the thing we're actually concerned with proving. We're able to take it as true. Like, I guess both parts of it are true. Because it's, I think it works because it's for any XYZ. If we only get specific XYZ that satisfied that, then sure. But it's any XYZ in the group satisfies this, so I don't know. That's my logic, at least. Wait. I don't put my universe statements, yeah. Or like being more specific about this group is made such that this relationship is true for every element in the group. I see. I could say that more for sure. Okay. I think it does imply that Lie algebra. You don't think okay, I mean, that's... It says for any x, y, z in the group. Oh, God. Like, every x, y, z in the group satisfies this. That's why I think it does work in this. I know, I mean... I feel like we need to get some lawyers in here to talk about the wording. It's oh yeah, I already checked. It's an even number problem, so we're not gonna call their lawyer. I don't know. I mean, it seems like regardless, there's like a way to do this without it. I don't know. I am getting towards like like I'm probably gonna do like problem or two, so I'm starting to get like a little like mentally tired. So if there is like potential doubt on the wording here or something, I'm willing to believe it, or on the way that I went about the proof, but out to my tired brain right now, it makes sense. Well, for any, that to me that's the key thing. Otherwise, I would agree with you. Every element in the group G has this as true. But if I am just reading that wrong, then I'm just not going to become a lawyer, I guess. It implies that I'm not going to be a lawyer. You need it to be true to have the conclusion. I think I'm going to leave it. It's like I just want to look at another problem. I don't want to have this debate more. It's not right now. I'd rather have another day, but like I feel like I'm not going to understand even a good explanation that's given to me right now. I appreciate you trying, but yeah, it's sleeping was a good way to say it. Like, um, I was gonna look at 24 more, but meh. Sorry about that. Oh no, underscore. It's fine. Like I would love to. I never mind people being picky with the stuff that I'm doing here because I need someone who's able to like tell me like, no, you're doing that wrong. Or like, you know, or you're technically right, but you should really like add in this other thing because I'm new to all this and I want to know like where those errors are. It's just in this specific instance, it's a really minute wording detail thing that we've been discussing for like I feel like half an hour or something. So I'm just kind of over it in this exact instance. But if you see anything else that I'm like missing or something like that, please do call it out. It's just like this exact one for now. I'm kind of over the conversation because I'm starting to get tired. Oh gosh, Anders. Okay. I don't want to go back into the entire thing, but it was. You know, I don't want to go to the entire thing. It was about 22. Whether we can assume that both sides of the implication are already true, and I'm just gonna leave it at that because I don't want to rehash the entire thing. Middle cancellation implying abelian? If that was a troll, I really respect it, but if you're honestly asking, I don't care either. Or rather, I don't like mind it, but I just don't want to go all the way back into it. So Fope was asking, I have a question about middle cancellation implying abelian. Do any of these look like middle cancellation? Oh, I mean that's right. That I guess we could do that too. Give an example of a group. Oh yeah, it's 39 in this book, Phobos. No, so I don't know if I'm gonna do this one, but let me actually see if Anders wants to hop in voice, like, we can maybe do that. Okay, so it was 22 in the book, or I also have it like copied up there. My thought was that we're given for any xyz in the group that xy equals zx implies y equals z, means that we can just I basically just used both sides of that implication that we were given. So I did substitutions with if y equals z, I substituted that back into xy equals zx to prove abelian. The trap of the empty statement. You can take an impossible statement and prove all sorts of things. Statement is empty. You don't actually have the properties. It just feels like we're in a situation where we're given it's not empty. I don't know. So, Andrew, if you have a thought on this, I'll probably hop in voice chat with you, but I don't know. We've been going back and forth on it for a long time, so. It's like I know that like the if thens can be vacuously true. I feel like the question is worded in such a way that we're in a magic land where we do get to do that, and it's not a vacuous statement. Yeah, that's very interesting. If you come up with anything, let me know. But we have opposing forces in both directions in chat on the side of the argument, I guess. So, I mean, maybe we'd say the question could be phrased different, but I feel like I don't know. So, I mean, I wouldn't mind trying the middle cancellation one as well. You don't know? No, that's fine, Anders. And if any like riggers in general want to hop in Discord to talk out a problem, I never mind either. Suppose, okay, can I figure out the idea of this proof at least? Suppose that G is a group with the property that for every choice of elements in G, AXB equals CXD implies AB equals CD. Oh, okay, you know what? No, I'm not going to this question. This is the exact same wording issue, isn't it? Yeah, okay, no. Well, let's keep going through more or less in order, skipping over the ones that seem lame. Oh. I definitely haven't already used this property. Maybe let's do 25 though. Prove it's abelian if and only if. Oh god, wait. Yeah, the algebra. It might have to do with 25 though. It might, but then why can't 25 be earlier? I don't know. I don't know how you prove 26 quite yet, besides saying just look at it, nerd. Set problem. So, underscore, I get that. I think the problem is worded such that we avoid that situation. To my reading of it, this problem does not apply to the thing that you're saying, is what is my thought. And what you said is true. I just think the problem doesn't apply to it. Or you gave a good example of like a logical fallacy that can happen. But the proof that I'm erasing now just wouldn't apply to it. That you don't have that all x, y, z I don't know how to phrase it now, but you in that example you put, you do not have the case that xy equals zx implies y equals z, or whatever the setup was. That's my argument. G is a group, then ensure the if statement can be used to gain the conclusion. That's exactly your point. I don't know. You don't know, man. It seems like there definitely exists a proof that, avoids this issue entirely, but like, I feel like mine should work too. Okay. G is abelian. If and only if AB inverse equals A inverse B inverse. Okay. You're kind of that we can't use the statement to gain information from the implication. You can't use the statement to gain information about the implication. I mean, you're just given that's not a fallacy, though. Like, it's a special case where it's not a fallacy. I don't know. That's the best that I can do for you right now, underscore. You may very well be right, and I'm just, you know, 6 hours into a stream, 6.5 hours into a stream, so I'm not at my best mental energy level. Obviously, because I can't even talk. I don't know. But the next time I stream math, I'll just look at an alternative proof, and I'll like know that like also works at the very least. But I don't know. I feel like it's an argument to be made for the proof that I did. So I think the easy direction will be from left to right. So let's start with that. So let's start with AB inverse equals B inverse A inverse by shoes and socks property, and then by being abelian, that's equal to A inverse B inverse. Easy. Reverse direction. So something that would satisfy G being abelian, we want to get that AB equals BA. We don't want any funky business with inverses being involved here, I guess. Can we just write multiplied by AB? Let's see what happens. Oh, yeah, maybe. And let's see what happens here. You get E. Oh, do we want to do this? We do. E. This feels like a pretty backwards way of proving abelian, though. It doesn't feel like it gets us. Wait, why did I make those inverses? Really, Eraser? You can't just stay there? Ugh. If we had now left multiplied by A inverse, left multiplied by B inverse. Okay. No, I keep doing inverses. Stop it, brain. Okay, we have Bay. Dude, even the red is running out. I do have a spare red cartridge, though, at least. A times A inverse is E, B inverse is B inverse, which is just E, A, B. Okay, there. Abelian. Done. Oh my god, Math Professor, if I'm able to catch that stream, I'm going to be tuning in. Invert both sides of the equation to the left of the implication. Oh, that'd be much quicker, wouldn't it? Yeah, okay, that's so much easier with the algebra. Just take the inverse of each side. All right, let's see if we can find another problem or two here. All right, the algebra. Thanks so much for hanging out. Since you're new around here, I don't know if you're already aware of the other math streamers, but there's a couple of good ones right there, as well as we've had Phobos stream hanging out. And you don't have to do anything at all with this information, but whenever I see new faces, I like to give shout outs to other math streamers. So if you're looking for more math streams, there's a whole bunch of them there. Sorry to flood the chat with stuff. Yeah, underscore. I think that's what we're saying. I've kind of lost track of what I'm saying at least now, but like if you were to rephrase the question, then there might be more of an issue, but I think with the way the question is phrased, we're okay. How do you even do this? I'm a little bit scared of this one. I thought it would just follow from this for some reason, but I don't actually know why that would be the case. Oh, I was wondering if you could do like, you take A as A inverse and B as E, and then when you plug in over here, you get something helpful, but no, you just go around in circles, I think. So I don't know if that's how you do 26, to be honest. Treated Z as a variable and replaced by some element like A, B, or something. I don't know what I did, if that's directed towards me anymore. It says replace the treats as variable replaced by some element A, B. I think the argument that math professor and I have been making, or at least math professors have been phrasing it much better than I have, is that with the phrasing of the question as it is, we're given that for any x, y, and z in the group, x, y equals zx implies y equals z. We're interpreting that as we can take just both of these statements as true for free and not worry about a vacuously true if-then statement. Yeah, so we can take each of these, like, x, y, and z as variables. I guess I don't know what you mean by treating them as variables. Like, I took x, y equals zx, and then I used this part of the implication to do a substitution. So I took z equal to y, so I said xy equals yx because z equals y. And then I said xz equals zx because y equals z. So I jumped rope, or I jumped between either side of this implication because I think we're given that both sides of it are true. But now I don't know. Nothing's making sense to me anymore. So if I'm phrasing it wrong, that might be. Ugh, I don't know. So I was arguing that it wasn't an issue. Snooky, it's bad. Yeah. I ate before I started the stream. I feel like the last long while has been a big debate on number 22 here. In the exact wording. 6 hours ago? You know. Who's counting? No, I am getting hungry. I'm about to like wrap things up soon. But I don't know. I just wanted to do a few more problems, I guess. Like I want to know what 26 is, but I feel like I'm not smart enough right now to figure it out on my own, so I kind of want to Google it. A inverse equals A. No, I'm not going to go for much longer. You just left? Oh, okay. So you know that A is an inverse of A inverse. And the inverse of A inverse is also an inverse of A inverse. Oh, we just use the uniqueness of the inverses. A inverse times A inverse equals E. Right. And then it's after that, would you say that the inverse is unique? Phobos? Then left multiplied by A. Really? Oh, I see what that. Oh, okay. That's nice. And then underscore saying you could call B equals A inverse and search B inverse. Boom, 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 boom. Dude, how many of these stream booth things am I gonna get this week? It's like the 6th one. Wait, oh. Now do the middle cancellation one? You really want to see it? It has the same issue though that has been haunting me for the last hour or whatever. Or like Darude, yeah. Still half trolling. I'm just seeing if I can figure out what the idea of the proof is without doing my trick. You can call it a trick. Oh my gosh, that's a good stretch. Oh yeah, okay. I don't see the idea. I think we should end the stream. I think I'm too like mentally tired to handle more right now. Um, I guess we can read out to Zach. What a day. A lot of math stamina. Yeah, I mean, it's been a fun day. We started off with that talk with Ben Center and Gold. That was a ton of fun. And Phobos, Bab equals Bab, Babe equals E-Babe. Babe equals E-Babe still. Bay equals EAB. Oh gosh. Okay, it's doing the same type of trick. Yeah, I will copy and paste it down onto a notepad, but I'm not gonna understand it that well right now. Slash in the middle. E to the 2i pi. Hey, these low-level tricks. Okay. So yeah, thanks so much everyone who's been hanging out with me. It's been a hell of a day. I don't know how I feel about that. About that debate. Like honestly, I don't even know what's right, but yeah, I just need to sleep on it. Tomorrow there'll be Gartic phone with the whole crew. I'll be starting my stream later than usual. And then my next math day will be on Saturday. Ooh, goodbye YouTube.